Okay, let's give you guys some practice. So let's say here you've got a car. When time equals 0, the car is 7 meters away from the tree. So let's say the tree is at the origin. It's 7 meters away from the tree at time equals 0, and the acceleration is always 3 meters per second squared. And precisely when time equals 2, the velocity will be 10 meters per second. I want to know the distance away from the tree when the time is 5 seconds. So how far away from the tree will the car be after 5 seconds? So press pause and have a go. Okay, so to do this, the car's acceleration is always 3. So A equals 3, always. That's acceleration of the car at any time. If you want to know, if you integrate the acceleration, it will then give you your velocity. So velocity will be 3t. When you integrate something, you will get a constant. So it's 3t plus c. So when you plot your acceleration time graph, it will look like this. The car will always have an acceleration of 3. When you integrate it, your velocity time graph will look like this. 3t, so it means that it will have a gradient of 3. But the thing is, plus c means it will give you a whole family of these straight lines. So you've got a whole family of these straight lines. But then if you look at this given condition, when time equals 2, when time equals 2, the velocity will be 10. So we can put this into the 10. We can put the 10 into the v. Put the 2 into the t, so that will then become this. That will then become 10 equals 2 times 3 will be 6. So 6 plus c. So c must be 4. So c must be 4. So c equals 4. So we can put 4 into the c. Put 4 into the c. So it's like this, plus 4. So what that means is we should be looking at this line here when the intercept is 4. So after 2 seconds, the velocity will be 10. The velocity will be 10, because if you think about it, if the acceleration is 3, it means this the velocity increases by 3 every second. So after 1 second, the velocity will be 7. It will be 7. And then another second later, the velocity will be 10. So an acceleration of 3 will mean your velocity increases by 3 each time. So we should be looking at this line here. So let's start again here. So we've got A equals 3, velocity equals 3t plus 4. So our velocity time graph will look like this. Velocity time graph, it will look something like this, where the intercept is 4. And 1 second later, the velocity increases by 3, so it will have a height of 7. And then another second later, it will have a velocity of 10, which is in line with our given condition here. Well, anyway, we are currently here. If you want to know the distance, then integrate it again. So distance equals, we'll integrate this. That would then give you 3t squared over 2. Integrate this, that will then give you plus 4t. And then anytime you integrate something, you will get a constant. So our distance, we will have a whole family of these distance time graph. So we will have lots and lots of these. We've got a whole family of these quadratics. But the thing is, this c here, we don't know which one we should be looking at. Well, if you look at this, when time equals 0, the distance away from the tree is 7. So what that means is, when time equals 0, when t equals 0, the distance away from the tree is 7. So put 0 into the t. Put 0 into the t. So that would be, well, the distance would be 7. Put 0 into here. The whole thing here would disappear. This thing here would disappear. So that would then give you c equals 7. So when time equals 0, the distance away from the tree is 7, meaning our c is 7. So we can put the 7 into this equation here. So what that means is our equation is this: erase the c and then put in a 7. So what that means is our intercept is 7 here. We should be looking at this quadratic here where the intercept is 7. So this is our distance formula. It will be 3t squared over 2 plus 4t plus 7. So now we want to know the distance away from the tree when time equals 5. So we can just put 5 into this formula. So that would be 5 squared would be 25 times 3, that would be 75 over 2, and then put 5 into here, that would be 5 times 4, which would be 20, and then plus 7. So this is a distance away from the tree after 5 seconds. So this is your final answer. Okay.